Okay, in this video, we're looking at balancing chemical equations. Now, you might have balanced in the past, whether it was last year in biology or maybe even in middle school for it. So we have to keep in mind the law of conservation of mass. It says matter cannot be created nor destroyed. The key is that it's going to be transferred into what we have as our starting, our reactants, to our products, or into something else or something new. Now, the key is that the whole reason we balance is that we want them to equal out from our reactant side to our product side here. And you can see that it's little like a scale, that if we have 4 H's on our reactant side, we need 4 H's on our product side. The same way for it. Now you'll notice that we talked about this number of a coefficient as a multiplier. And we're going to see that we use these coefficients as we go through to balance it. So these coefficients can only be placed in front of what you are balancing, and they are a multiplier. So if we look at this example of 3MgOH2, we would need to multiply that 3 into each one. Now, when there is one on the outside, that's like saying we had 2 and we had 2. So how many mg's would we have? So we had 1. 1 times 3 is 3. We had O, which was 1 times 2 on the outside of the parentheses, which is 2 times 3 is 6. And then we had H, which was 1, then the 2 multiplied in, so that's 2 times 3 is 6. So that's how we would use it as a multiplier. You can only put coefficients in the front. You can't put them behind it, in the middle, or anywhere else. So when we start to balance, you'll see that there is a line for the coefficient on where the number needs to go for it. So there are some rules as we're going to be balancing these different chemical equations. So what we're going to see is that you're always going to find the arrow. Remember our yields. And then you're going to draw a line between the reactants and products so then you can see what you have on each side. So you're going to make the same list on both sides of the line. Now you're going to count how many reactants and then count how many products you have for it. Then you're going to add coefficients in the front that is a multiple of what you're trying to make it look like. Then change the numbers accordingly in the chart down below. Continue going back and forth until both sides of it are equal. Now, some of it's a little guess and check, or as you get more comfortable, you'll see common multipliers for our balancing equation. So let's get started with our first example. We're going to do this one together, and you can see that the line in the chart of what you have is already put in. So we see we have WO3 plus C yields W plus CO2. W is just tungsten, and it's in the middle of our periodic table. So the step one was to find your arrow and draw your line. Then you're going to make your list. So W is going to be how many? We see no number, that's 1. We have O, we see a 3, and then we have C, which is no number, is a 1. Now you make the same exact list, even though you don't see it in the same order on the product side, because we want to make sure that we are evenly balancing this out. So we see W again just as 1, we see C as 1, and we see O as 2. So what we're going to do is need to balance it out. So I have a 1 and a 1. Okay, that seems fine. I don't have to do anything with W yet. So now we have a 3 and we have a 2. So we're never going to make a 3 look like a 2 or a 2 look like a 3, but we can think of a common multiple between the two. So what can we multiply 3 by to get the same number as 2? So we're going to see their common multiple is 6. So you're going to find where the O is, and then you have to put the coefficient in front. So 3 times what gives you 6? 2. So it not only changes the O, but it does the W. So we're now going to have 2 W's, and then we're going to have 6 O's. Now, before you start changing your W's on the product side, go and change your oxygen first. So 2 times what number gives us 6? 3. So it not only does the O, but it does the C too. So C would now have 3. 2 times 3 would now give us 6. So we'll actually see that our W's are no longer balanced, but we'll see that our O's are balanced. So I'm going to keep going down the list. I have a 1C on my reactant side, and I have a 3 on my product side. So what can we multiply 1 by to get to 3? 3. Perfect. So I'm going to change that to 3, and those two are balanced. So now I go back up to the top. I have two W's on my reactant and one on this side. What can I multiply 1 by to get 2? It is 2. So I'll put a 2 here, 2 and 2, and we are balanced. And then we can add it up too. So our reactant side would have 2 plus 6 is 8, plus 3 is 11. 2 plus 6 is 8, and 3 is 11. So we are balanced or equal between it. Now, you may see it on future multiple choice tests or when we're checking your answers as a 2, 3, 2, 3 for it. So let's try one more example together. Okay, we have CaO plus Al yields Al2O3 plus Ca. So remember, we're going to find our yields and draw our arrow down, and then we're going to make our list of each one that we have. Notice that the list is the same on the reactant side as it is on the product side for it. So now we're going to look and see how many we have. If there are no numbers behind it, that just represents that there's one. So we have one Ca, we have one O, and we have one Al. We have one Ca, we now have three Os, and we have two Al. So our Cas are already balanced, so that's pretty awesome. And notice how I said they're already balanced and I didn't add yet. So we might have to change it, but we'll see. So we have a 1 and we have a 3 here. How do I make a 1 look like a 3? I would multiply it by 3. So I'm going to put my 3 up here, and not only changes the O, but it also changes my Ca. So now my O's are good to go, but it now changed my Ca. I'll come back and do the CA at the end. I'm going to keep going down the chart. So how do I make a 1 look like a 2? I need to put a 2 because 2 times 1 gives me 2. So now my ALs are okay. And then I have 3 of my CAs on my reactant side. How do I make a 1 look like a 3? I'm going to put a 3 here. And then we are all balanced for it. So on this line, you can leave it blank, but I like to put a 1 in there just to let me know that I finished this problem for it. So we have a 3, 2, 1, 3, and then don't forget to check what we have. We have 3 plus 3 is 6 and 8. 3 and 3 is 6 and 8. And that takes us through going through the basics of balancing. Now you're ready to try some on your own.